Interpreting IR scans for experiment 10, the nitration of chlorobenzene upon nitration yields a mixture, roughly equal mixture of ortho chloronitrobenzene and para chloronitrobenzene. So in general, you must make assignments for the major characteristic absorption bands of the reagents and products. So briefly, look at the structure of the molecule so that you identify what functional groups are present. Look at the generic scans for the compounds so you can see what they look like, and look at the IR assignment tables to get details of what you need to record, and finally make those assignments on the scans of your samples. So step number 1, what's present in the compounds? Well, I have here the structure of one of the products, ortho chloronitrobenzene. Recall that the reagent will not have the nitro group in it, so it'll be chlorobenzene with a mono-substituted aromatic ring and a chlorine. The two products, ortho and para chloronitrobenzene, will contain a di-substituted aromatic ring, a chlorine, and also a nitro group. So step 2, let's look at a generic scan. Now, as it turns out, I don't actually have one for a nitro compound in the notes, so I just generated one using know-it-all, drew the structure of nitromethane and asked it to reproduce the IR spectrum. So this is an aliphatic, a nitro compound. We'll be doing an aromatic, so there's some similarities and some differences. First of all, from these 6 peaks, 4 of them actually derive from the methyl group. Just below 3000 we have the asymmetric and symmetric methyl stretches, and then at 1460 and 1380 respectively we have the asymmetric and symmetric methyl bends. Now these two large bands at 1530 and 1370 are NO stretches from the nitro group. They will be at slightly different wave numbers in the aromatic compound. Now there is one other fairly important absorption for a nitro group, and that's a C to N stretch that we'll see in the scans, but unfortunately know-it-all didn't generate that one for us. Okay, so continuing with step 2, let's look at some generic scans for some substituted aromatics. So we have the mono-substituted reagent, chlorobenzene, and I want to focus specifically on the region from 700 to 900 or 650 to 900 wave numbers. So for a mono-substituted aromatic, we have absorption at about 690 and 770. For the ortho di-substituted aromatic ring, we'll see a single absorption band just below 800, approximately 770 wave numbers. And for a para-di-substituted aromatic ring, we get again a single absorption band, this one just above 800, typically around 830 wave numbers. So these are usually pretty easy to pick out on an IR spectrum. Step 3, we go to the assignment table. At least in the case of chlorine, recall that a carbon to chlorine stretch occurs somewhere in the broad range of 550 to 850 wave numbers. So it's quite a wide range and makes it difficult to nail down exactly. So here is the IR assignment table for nitro compounds. And there are 3 regions we want to look at. We've already mentioned that for an aliphatic nitro compound, there's an asymmetric and a symmetric NO stretch at 1550 and 1370 wave numbers. Now we'll actually be dealing with aromatic nitro compounds, and these are described as being conjugated. So here you see the aromatic ring is in fact conjugated with the pi system of the nitro group. I have pi, sigma, pi. And that conjugation tends to lower the absorption bands of the asymmetric and symmetric NO stretches to about 1530 and 1350 respectively. Still pretty easy to identify. A CN stretch occurs at about 870, and we may in fact see a C to N bend in the region of about 610. Now, it is said that this may in fact alter the position of the out-of-plane bends and move them a little higher, and hence detract from or ruin or perhaps destroy the reliability of the outer plane bends for identifying the substitution patterns in aromatics. We'll do the best we can. Another note of caution here is that nitro groups absorb in the same region as aromatic compounds, where the phenyl nucleus absorbs at 1600 and 1580 and 1500. Notice we have the NO asymmetric stretch. And then if you had methyl groups in your compound that have symmetric bends at 1380, that's very close to the 1350 symmetric stretch of the NO group. So there may be some conflict there. However, these NO stretches tend to be broader, and with some care they can be identified and distinguished from these other groups. So here's the first scan, a chlorobenzene. It's monosubstituted. We would look for the chlorine absorption somewhere between 550 and 850, and we expect to see two outer plane bends, one at 690 and 770. So in fact, this one in the middle might be the chlorine. I'm not asking you to specify which is which, but I've grouped all three together. Just list all three. Here's the Ortho chloronitrobenzene. So it will have the chlorine somewhere between 550 and 850. We'll have the Ortho disubstituted absorption just below 800, somewhere in this region. And then we'll have the C to N stretch at about 870. So as to which is which, I'm not sure, but again, you don't have to identify, just list the ones that should be present. And here is the para chloronitrobenzene. Again, we expect to see chlorine somewhere between 550 and 850. Not exactly sure just where. The para substituted aromatic has a single absorption just above 800, typically somewhere around 830, could be that. Then we have the C to N stretch here, which is typically around 870, kind of overlapping. And this appears to me to be an overlap of the C to N stretch as well as the outer plane bend of the para substituted ring. Can't be sure, but that's best guess. So you will have a total of 4 scans to interpret for this lab. You'll have the reagent, pure chlorobenzene, and 2 products, pure ortho nitrobenzene and pure paranitrobenzene, and of course you have your recovered product as well. Now your recovered product will contain both ortho and parachloronitrobenzene, and it may even contain some unreacted chlorobenzene, so expect it to be very busy in the 700 to 900 wave number region where the outer plane bends occur. The TLC of your recovered product should show evidence of at least 2 products, if not the reagent as well. So enjoy.